In section 4.3, we're looking at applications of systems of linear equations. Our objectives are to solve geometric problems, money problems, mixture problems, as well as distance rate problems using two variables. This slide shows a 6-step process for solving an applied problem by writing a system of equations. Step number 1 is read the problem several times if necessary. What information is given? What is to be found? This is often stated in the last sentence. Step number 2 is to assign variables to represent the unknown values. Use a sketch, diagram, or table as needed. Step 3 is to write a system of equations using the variable expressions. Step number 4, we want to solve the system of equations, which we looked at in our last section, either using the graphing, substitution, or elimination method. Step number 5 is to state the answer to the problem and label it appropriately. Does it seem reasonable? And finally, we want to check the answer in the words of the original problem. In this example, we are asked to find the dimensions of a parking lot. The length of a rectangular parking lot is 20 feet more than 3 times its width. The perimeter of the parking lot is 800 feet. What are the dimensions of the parking lot? Well, what we have here are two variables, two unknown quantities, the length and the width. So we are using L to represent the length of the parking lot, and we're going to use W to represent the width. Using the first sentence, we see that the length of a rectangular parking lot is 20 feet more than 3 times its width. So with those words, we're going to convert that to an equation. Our first equation being L, the length, is, which means equals, 20 feet more than 3 times its width. So we're going to do 3 times W plus 20. So that is showing 20 feet more than 3 times its width. The perimeter of the parking lot, looking at the second sentence, we say the perimeter is 800 feet. Well, if we know that the formula for the perimeter of a rectangle is 2L, 2 times the length plus 2 times the width, and we know that this perimeter is 800 feet, then we can say the equation 2L plus 2W is equal to 800. Now this represents a system of equations. We have our first equation as L plus 200, L equals 3W plus 20. And then we have 2L plus 2W is equal to 800. So we've got our first equation and our second equation, and we can use the substitution, elimination, or graphing method. We'll go ahead and use the substitution method. We already have the first equation solved for one of the variables, so what we'll do is we'll take the L in the first equation, what that is equal to, and substitute it into the L in the second equation. All right, so this equation that we're looking at is 2L plus 2W is equal to 800, and we are substituting the L from the first equation into the L in the second equation, and that will look like 2 times 3W plus 20 plus the other 2W is equal to 800. We're going to distribute the 2 here and solve this equation for W. When you distribute, you get 6W plus 40 plus 2W is equal to 800. By combining like terms, we get 6W plus 2W is 8W plus 40 is equal to 800. And then by subtracting 40 from both sides, we get 8W is equal to 760. And then by dividing both sides of this equation by 8, we do get the value for W is equal to 95. Now we can plug this answer back into the first equation for W and solve to get L. So that is going to look like L equals 3W. Instead of W, we're going to put 95 plus 20. And when we simplify that, we get 305. So what we have here is make sure we answer our problem using words. We could say that the length is equal to 305 feet and the width is equal to 95 feet. So those are the dimensions of the parking lot. We're asked to find the dimensions. And our last step is to make sure our answer checks in both of the original equations. So let's look at our check step here. Check. So if we let L equal 305 and W equals 95, we want to make sure that works in the first equation. So does L equal 3W plus 20? So L is equal to, oops, go back a sec. All right. So L being 305, does that equal 3 times 95 plus 20? And then we get 305 equals 285 plus 20. So we see that is correct. So it works for the first equation. We also want to check the perimeter. Does that perimeter equal 800 feet? And recall the formula for the perimeter is equal to 2L plus 2W. And if our P is equal to 800, that's 2 times the length of 305 plus 2 times the width of 95. We're going to multiply those together, 2 times 305 to get 610, and 2 times 95 is 190, and then 610 plus 190 does equal 800, so it also checks in the other equation. So as a recap here, we were able to solve this system of equations, solve this application by setting up a system of equations, and in this case we use the substitution method. In this example, we're solving a problem about prices. At a local restaurant, the price of 1 soft drink and 2 hamburgers is $12.15, and the price of 5 soft drinks and 4 hamburgers is $32.25. Let's find the price of a single hamburger and a soft drink. To begin, we have unknown quantities in terms of the price of a hamburger. We're going to let H represent the price of a hamburger. And we will let S represent the price of a soft drink. Now you can use any variables. You can use X and Y as long as you clearly define your variables. Now at the first part of the sentence, the price of 1 soft drink and 2 hamburgers is $12.15. So the equation that you can come up with there would be 1 soft drink, that's S, 1S, plus 2 hamburgers, 2H, that is equal to $12.15. The second part of the sentence says 5 soft drinks and 4 hamburgers is $32.25. So the corresponding equation would be 5S plus 4H is equal to $32.25. So we have our system of equations. What we can do here is get opposite terms and use the elimination method. We can get either opposite S terms or opposite H terms. And if we look at the H terms, we can find the least common multiple of 2H and 4H. So let's find the LCM of 2H and 4H. Least common multiple is 4H. So we want one of these to be a positive 4H and the other to be a negative 4H. So we need to figure out what to multiply the first equation by to make it a negative 4H. And what we're going to do is multiply by negative 2. Since the second equation already has a positive 4H, there's nothing we have to do to the second equation. So let's multiply the first equation by negative 2. And again, whatever you multiply the left side of the equation, multiply the right side by the same value. And the resulting equation, we can write below here, is negative 2s minus 4h equals $24.30, negative 24.30. Now we are looking at these two equations. And notice we have opposite x terms here. So we can add the equations together and we get 5s minus 2s is 3s. The positive 4h and the negative 4h are opposites, so they're going to cancel out. And we have $32.25 minus $24.30, and that is going to equal $7.95. And then we can divide both of these equations by 3 to get our answer. S equals $7.95 divided by 3. That's going to be $2.65. Now let's find the price of the hamburger. So you can take either one of the original equations. I'm going to start off with the first original equation, which was S plus 2H, one soft drink and 2 hamburgers, equals $12.15. I'm going to replace the S in this equation with the $2.65. And that gives us 2.65 plus 2h equals 12.15. I'm going to solve this equation for h by subtracting 2.65 from both sides. And the result is 2h equals 9.5. And then we can divide by 2 on both sides. And we get h equals 4.75. So the price of a hamburger is $4.75. And then our last step is to check, make sure that one soft drink and 2 hamburgers gives you $12.15, and 5 soft drinks and 4 hamburgers is $32.25. Okay, in this example, we're solving a mixture problem. How many ounces each of 10% hydrochloric acid and 25% hydrochloric acid must be combined to get 40 ounces of solution that is 22% hydrochloric acid? So we are given the information. Actually, this one is helped set up this equation by the fact that we're using X to represent the number of ounces of the 10% solution, and we're going to let Y equal the number of ounces in the 25% solution. When you're solving these mixture problems, it's really helpful to set up this table. Our first column shows the percents. The first solution is a 10% solution, and that's represented as a decimal as 0.10. The second solution is that 25% solution, and that's represented as a decimal 0.25. Now, these are the two percentages that we're starting off with, and then what we want to end up with is a mixture that's 22%. of the hydrochloric acid. And that represented as a decimal is 0.22. Now, we're not sure how many ounces of the first percentage, so we're using the variable x for that quantity and the variable y. And we do know that when you add those together, you're going to get the 40 ounces. So that's why we have the number of ounces of our result is 40. Now in the last column here, the way you calculate the ounces of pure acid is to take the percent times the number of ounces. So in this column, we're going to take 0.10 or 10% of x, and that can be represented as 0.10x. The 25% is 0.25. 25% of the y ounces is pure acid, so we're going to multiply 0.25 times y. And then our result is going to be 40 ounces, and that percentage is 22%. So to find the ounces of pure acid, we're going to multiply 0.22 times 40 to get 8.8. Now from the table, we can set up a system of equations. Let's move this up a little bit. Now the amount of liquid altogether, or the amount of liquid altogether is 40 ounces. X ounces of the first percent, Y ounces of the second percent, and that's going to equal a total of 40 ounces. So our first equation can be represented as X plus Y is equal to 40. Our second equation is going to tell us about how much pure acid is in the mixture. So that if you take what you start off with, the 10% of X and the 25% of Y, and that's going to equal 8.8. So our second equation can be written as 0.10x plus 0.25y is equal to 8.8. And that's our system of equations. We can use the elimination method, the substitution method. Graphing method might be a little challenging, so let's go ahead and use the substitution method. We can take one of the original equations and solve for one of the variables. What I'll do is I'll take the first equation and solve it for y. So if I know x plus y is equal to 40, and I subtract x from both sides of the equation, then my equation is y equals 40 minus x, or negative x plus 40. You can write it either way. And then you're going to substitute that quantity into the y in the other equation. And the result there would be 0.10x plus 0.25 of negative x plus 40. Again, I replace that y with negative x plus 40, and that equals 8.8. Now I'm going to solve this equation by using the distributive property here and combining like terms. And the resulting equation is going to be 0.10x minus 0.25x plus 0.25 times 40, which is 10, equals 8.8. Now I'm going to combine like terms and solve this equation for x. I know that 0.10x minus 0.25x, these are both like terms. I can combine those to get negative 0.15x. I can also subtract 10 from both sides of this equation, so that I get negative 0.15x is equal to negative 1.2. Now by dividing both sides of this equation by negative 0.15, I can finally solve for x. So x is going to equal 8. So that lets me know that the number of ounces of the 10% solution is going to equal 8. So 8 ounces. And then I've got to figure out how many ounces of the 25% solution. So I can go back to this equation here. If I know what x is, I can substitute that in to find y. Y is equal to negative x, or negative 8 plus 40. So y is equal to 32. So that means this amount of the 25% solution is 32 ounces. So the way we can write our final answer is, say the 10% solution, we're going to have 8 ounces of 10% solution, 10% hydrochloric acid, and the other amount is 32 ounces of the 25% solution. If you mix those amounts, you're going to end up with 40 ounces of 22% solution. All right, example number 4, we're solving a motion problem. A car travels at 310 miles in the same time that a bus travels 290 miles. If the speed of the car is 4 miles per hour faster than the speed of the bus, find both speeds. Now we're going to assign variables to the unknown quantity. We don't know how fast the car is traveling, and we don't know how fast the bus is traveling. So we're going to use variables. We're going to let x represent the speed of the car and y represent the speed of the bus. Now this equation we're going to use a lot whenever you have these distance or rate or time problems. We're using the fact that distance is equal to rate times time. And by dividing both of those with r, you can get the equation for t. I want to really point out, make a point of talking about this equation because it's used so much for these motion problems. Distance is equal to rate times time. So d is equal to r times t. That's our basic distance equals rate times time equation. If you take this equation and divide both sides by r, then you get t by itself. T is equal to distance divided by rate. Now again, if you go back to your basic distance equals rate times time equation, instead of dividing both sides by r, when we divide both sides by t, then we can solve this for the rate and get the equation for the rate is equal to distance divided by time. So when you're solving these motion problems, you're either going to be using the equation distance is equal to rate times time, or time is equal to distance divided by rate, or rate is equal to distance divided by time. And it's always helpful to set up a table for these types of problems where you have columns, distance, rate, and time. Now, this table is set up for us already. Let's move that over there. Make this a little bit bigger here. The distance information that we're given is that the distance a car travels is 310 miles. So that's why in this distance column we have 310. In the same amount of time that the bus travels 290 miles, so the bus distance is 290. The actual rates, the speeds are unknown, so we are using x and y. And then for the time is the same amount of time. So the way you find what goes in this column for t is to take the distance and divide it by the rate. So in this column we're going to have time, which is 310 divided by x. And for the bus travels 290 miles at a rate of y. So the time for the bus is distance divided by the rate, and that will be 290 divided by y. So our equation now that we can come up with the system of equations is the fact that we know that the speed of the car is 4 miles per hour faster than the speed of the bus. So we're going to make an equation that relates x and y. So the speed of the car, that's your x, is 4 miles per hour faster than the speed of the bus. So x is equal to y plus 4. Now the other equation we get for the system of equation is, again, going back to the times are the same. So the time for the car has to equal the same time for the bus. So the other equation is going to be 310 over x has to equal 290 over y. And that's our equation, our system of equations. We want to solve the system of equations. We can do this using substitution or elimination method, and because this is already set up where one equation is x solved, we're going to substitute that into the other equation. Okay, let's get some more space on the page here to do that. Excuse me. So let's take the second equation and substitute in the first equation. So we have 310 divided by the x, but x is y plus 4. That has to equal 290 divided by the y. Now what you can do when you have a fraction on one side is equal to the fraction on the other, you can cross multiply. So our new equation, our resulting equation, is found by multiplying across. 310 times y is 310y, and 290 times the quantity y plus 4, that is 290y plus 290 times 4, which is 1,160. Now we have this equation, the single equation with a y. We can solve this by subtracting 290y from both sides, and the resulting equation is 20y equals 1160, and then we divide both sides by 20, and we get our y equals 58. Now the y is the speed of the bus, so that's going to be 58 miles per hour. Now we're going to use this first equation again, what we have for x. X is equal to y plus 4. And since we already found y is 58, we're going to substitute that in. So we get x equals 58 plus 4. So x is equal to 62, and that's miles per hour. So our final answer should be describing the speed, making it very clear. So the speed of the car is traveling at 62 miles per hour, and the bus is traveling at 58 miles per hour. And you can double check that in that whatever amount of time you get, in the same amount of time, the distance a car travels is 310, and at the same time the bus travels 290.